Welcome to the Statistic in ED YouTube channel. Today I'm excited to talk about how to plot data from databases in R with a special focus on how to do it efficiently and introducing the dbplot package that you may not have heard about. By the way, this is my first video that is based on a Sharingen presentation, so let me know in the comments what you think of this format. If you like it for videos, I like it because it gives me some nice options, which I hope you will see in the next couple of minutes. So what do we want to do? I want to quickly introduce the main idea, what makes plotting from a database efficient or non-efficient. I want to introduce the data that I'm using. It's about musical albums and songs and their success in worldwide charts. Then we'll set up an in-memory database so that we can try out the examples without having to worry much about infrastructure. And then I'll show you a couple of examples. We'll start out with simple bar plots and see different approaches how to do that and how these approaches differ. Then we'll check out a histogram, and then finally we'll see a scatterplot versus a raster plot, which I think is a powerful idea for plotting. So what is the main idea? When data is in databases, there's often a good reason for that. Usually the data is quite large, and so the main bottleneck is how much data you have to transfer from the database to R's memory. And as it turns out, a lot of visualizations don't require access to the full data set, but only to aggregated data. So best practice is to run data transformations as much as possible in the database and only plot results in R so that you only have to push aggregated data to R. So this is the data we'll be using. It's from the great website tsort.info, and I encourage you to check it out. We have 71,000 songs and albums just about in there, and we're free to use this data as long as we point out the source, link to their website, and specifically mention the version. Here we're using version 280044. The size is 26 megabytes just about, so it's not really huge data, but it's sufficient for this purpose of this presentation. So this is what the data looks like, just the first couple of lines. The most successful songs and albums, so sorted in descending order by score. You can read on the website how the score is calculated. It takes into account worldwide chart information, and there's some weighting system behind it, so it's a little bit complicated. It's not sales, but chart success, we can say. So the higher and the longer the charts a song or an album was, the more points it gets, and also taking into account the size of the music market and so on. Right, so we'll create an in-memory database. You see the code here, and you can also find the code on my GitHub profile, which is linked to in the description. So an in-memory database, and then we use dplyr to copy our data to that database. And you see it's a SQLite connection. Right. So now let's start with simple bar plots. I'm using Theme Economist here from the GG Themes package. So there's some filtering. I just focus on the top 5 bands and artists, top 5 in terms of total score. And here you see at the bottom I'm using ggplot and the geombar function. And this approach works, so I get the result I wanted, but it's an inefficient approach because all the data is pulled to R's memory, and geombar does the calculation of the summary statistics here, the counts for each band or artist. So a lot of data has to be transferred to R. So a better approach would be to do the calculations within the database. We do that here. We can do that manually using dplyr syntax, and then dbplot translates that to SQL and sends that to the database. So we can use functions like group by and tally here, and then collect transfers the aggregated data to R, and then we switch from geombar that we used before to geomcall. Geomcall just takes a variable for the summary statistic here, the counts on the y-axis and the variable n. So here only 5 data points are pulled into R's memory, so we get exactly the same plot, but the calculation is much more efficient here. The downside is that manual calculations in the database can be a bit tedious to do, and we wouldn't always like to do that by hand, so it's better to use a dedicated package. And this is what the dbplot package is meant for. It's by Edgar Ruiz, a great effort, so we can be thankful to have this package in our toolbox. And here you see I simply use the dbplot_bar function. The code is much shorter now. I don't have to worry about the aggregation. The summary statistics and the calculations are done inside the database. So this is a very efficient approach. It's very fast. Only 5 data points are pulled into R again. Unfortunately, there's a little downside to this approach. This combination of doing the calculations in the database and using this dbplot package, I don't have access to all the functions, for example, from the tidyverse that I would like to use inside the database. For example, the forcats functions that I used before here on the previous slide, I used the factor in order function from forcats. I can't use that in this approach. So a solution to that is to again do the calculations inside the database, but not use the shortcut dbplot_bar that I used here. But here I use dbComputeCount. So there's a compute function that does the computations in the database. It's shorter than our manual approach from before. And then I can switch back to the geomcall function that we've seen before from ggplot that does not do the aggregation because we have done it ourselves. And geomcall just takes values that are already provided. And now with this approach, I have the perfect mixture of A, doing the calculations inside the database, and B, being able to access functions like factor in order from the forcats package. And now the bars are sorted in descending order again to give a nicer visual representation. Right, so next example is a histogram. Here we go the easy road again, just using the dbplot_histogram function. We can specify the bins. So plotting histograms, it's always recommended to try out different bins because then you might get different impressions of your data. So very simple, just a one-liner to create the histogram, and all the necessary calculations are done inside the database, and ggplot only needs access to this aggregated data, so efficient again. And now last plot type that I want to talk about today is a scatterplot. So here it's an inefficient way again. First of all, we look at the scores and some summary statistics. So we see the maximum is 54, but the distribution is very much skewed. You see the mean is below 2 and the median is even below 1. So the majority of songs and albums are in a very low range of scores, and there's only very few songs and albums that scored higher. So we have a lot of overplotting here in the low score ranges in the scatter plot. And this approach again is very inefficient because all the data has to be pulled into ggplot. So there's a lot of data transferring going on, and then the plotting itself is also slow because there are so many data points. So I want to show you an alternative that can give us a similar impression. It's called a raster plot, and the idea is a bit similar to a histogram. A histogram bins values into categories, and the raster plot creates two-dimensional bins. So we have bins along 2 axes, and you can see, similar to a histogram, I can specify the resolution here. So we have a 40 by 40 matrix, and each square on this plot represents all the data points that fall within that square, but it's just an aggregated number. And you see the coloring illustrates how many points fall into that bin. So we get the same impression, the same story that the scatter plot from before told us as well. The lighter colors are only in the very low ranges, so we see that the vast majority of songs and albums fall in low ranges, low scores, and we only have few values with higher scores. So an efficient alternative to the scatter plot that also gives us an impression of the two-dimensional distribution, and yeah, all the heavy lifting, the calculations are done inside the database, and R sees only aggregated data and is very quick to plot this. That was pretty much it. Let me know if you like this format, also with syntax highlighting that I get here. I like it because all my R code is in a Markdown document. Sharing is built on top of Markdown, so I don't have to copy plots or R code from R or RStudio to a presentation. It's all in one document. Right, to finish off, just a quick overview of the two families of functions that the dbplot package offers. We have plotting functions and we have calculation functions, as we saw before. You see also that the choice is limited compared to what ggplot offers, so it's not like as fully developed as ggplot, but it does give you access to some nice plotting functions that do calculations inside the database. And if you prefer not to use the plotting functions directly, but if you want to get the aggregated data, you can use the calculation functions. Right, so all the credit for these ideas that I presented here goes to the awesome RStudio team. There's a dedicated website that I really encourage you to check out at db.rstudio.com. That gives you a lot of information on how to access databases from R, not only plotting, but with regard to this video, there's a dedicated part of this website, best practices creating visualizations. And you know that RStudio became a public benefit corporation in early 2020, so the R community can really be thankful that so much work is made accessible for free. Right, that was it. I hope you liked the video. If so, give it a thumbs up. Consider subscribing to the channel if you haven't already. All the best for your R projects and your visualizations. See you next time. Ciao.